Hey everybody, today we're going to start Chapter 10. Chapter 10, we're going to be dealing with probability throughout Chapter 10. I hope you're excited. I hope you're buckled up, ready to go, because here comes 10-1. Today we're going to be learning about how to find the probability of an event by using the definition of probability. Go figure there's a definition of probability. Okay, so there's a few vocab words you're going to be talking about. And here's the first four. So pause now, write this down. All right. So first, you have an experiment. An experiment is an activity in which results are observed. If you look at experiments in science class, science. Okay, science class, you are looking at different things that you are observing. How fast is that car going down the ramp? What if I increase that ramp angle? How fast is it going now? How far does it go? All of these questions are answered in experiments. Then you have trials. Each time you make an observation, it is a trial. An outcome, each result. There are multiple different outcomes to different experiments. Every outcome or every result is known as an outcome. The sample space would be all of the possible outcomes of an experiment. If you look at these, to give you an example, you could look at this. Here's this little, I could have divided this out a little better. There we go. Okay, flipping a coin is an experiment. The sample space are the total outcomes. When you flip a coin, you can get heads or tails. Just heads or tails. You can't get body. Heads or tails. Then, rolling a number cube, just a regular number cube, you get 1 through 6. You don't get 7, 8, 9, 10 unless you have 2 dice. Or 2 dice, not 2 dice. Then, guessing the number of marbles in a jar. If you go to the carnival and you look at that and they say, step on up, guess the number of marbles in this jar. If you guess the number of marbles in the jar, you get all of the marbles. Wouldn't you want to get all those marbles? Yeah, that'd be awesome. Okay, but if you are guessing the number of marbles in that jar, you're dealing with whole numbers. They're not going to take those marbles, cut them in half, cut them in fourths, cut them in eighths. Why? Because that'd be a little bit difficult to guess 364 and 1/8, 372 and 5/19. Doesn't make sense. So you're dealing with whole numbers. Okay, then you have event and probability. Pause the video, write this down. All right, so an event is any set of one or more outcomes. There can be more than one outcome for this, okay? Going back to that, think about rolling a die. You can get more than one outcome. The event of a 5 being rolled, the event of a 6 being rolled. Those are events. They can be more than one outcome. Then we're dealing with probability. Okay, when you think of probability, what comes to your mind? A lot of times you think about percents. You think about probability of winning the lottery. At least that's what I think of. And it's very low. So I won't win the lottery. So when you win the lottery, send Mr. Sheeman some. Okay, so anyways, it is a number from 0 to 1. It's between 0 and 1. What's a number between 0 and 1? Well, we have 0.5. Well, we have 0.6. Well, we would have 0.127. Okay, it's the likely event that is about to happen. Written in the probability is written as the event inside your parentheses. It's between 0% and 100%. We're going to talk about definitions to those. Then, all probabilities, all of the outcomes. If you added up all of the outcomes, it will equal 1 or 100%. Equal 1 or 100%. Next. Then you have something called impossible and certain. Impossible and certain. Okay, pause the video, write these down. All right, there's things that we deal with impossibilities and there are things that deal with these certainties. All right, so if I look at this, I'm going to find the probability. Okay, the Wild and the Blues, they're going to be playing a game tonight. Go Wild. Okay, they're going to be playing a game, and they either between the Wild and the Blues, right? I'm going to say, what is the probability that the Wild or the Blues will win this game? Well, if the Wild or the Blues will win this game, the probability of one of them winning is 100%. I guarantee it is certain that either the Wild will win or the Blues will win. One or the other. Now, if I ask you this same question, the probability of, let's say, the Capitals winning a game between the Wild or the Blues, is that going to happen? No. No, it is not going to happen. The Capitals are not playing the game between the Wild and the Blues. The Xcel Center will not allow the Capitals to come in, jump on the ice, throw the puck in the net a bunch of times, and win the game. It won't happen. Why? Because three teams aren't going to play the hockey game. All right? That's what it is. All right, so here's our first problem. We have a problem on forecasting. Now, meteorologists, they can be right, they can be wrong. Chances are they're going to be wrong. But here's the meteorologist, what they expect for this day. So pause the video, write this down. Okay, so you have the weather forecast calls for 60% chance of rain. Give the probability for each outcome. Now, as you look at different outcomes, different probabilities, you can deal with percentages, you can deal with decimals, you can deal with fractions. It does not matter to me which one is which, okay? You can deal with one or the other. I would deal with the easiest ones to write down from based on the question, okay? This question asks, it is dealing with percentages. So let's stay with percentages. Why? Because it's easy. So as I look at this, the weather forecast calls for 60% chance of rain. So what is the probability that it's going to rain? 60%. Why? Because the guy said so. Okay, then if it's going to rain or not rain, those are the two possibilities. Well, if there's a 60% chance of rain, then there's a 40% chance of no rain. Why is there 40% chance of no rain? Because both of these added together need to equal 100%. Just like I said before, it needs to be, probability needs to add up to 1 or 100%. Okay, 1 or 100%. Okay. Next. All right, so what I want you to do is I want you to write down the table, and I want you to write down these two questions. Question here, question here. Do not worry about the directions right now. So just write the table and the two questions. And go. Oh, and give these two a shot. See if you can come up with the answer. And go. All right. Here we go. Welcome back. Here we go. It says a game consists of randomly selecting 4 colored ducks from a pond and counting the number of green ducks. Have you ever played this game at a carnival where you're sitting there, you've got this pond going, ducks are floating, everybody's happy, and you pick up a duck and you want to see if you win? I like those games because chances are you're always going to win. All right, but anyways, it says the table gives the probability of each outcome. It says, what is the probability of selecting at most, one green duck? We're just looking for that one green duck. I want to find at most one green duck. So looking at this table, could I, if I'm selecting at most one green duck, could I pick 0 green ducks? Yeah, I'd be pretty sad, but yeah, I can pick 0 green ducks. All right. At most one green duck, could I select 1 green duck? Yep, that would satisfy that problem. Could I select 2 green ducks? No, I could not select 2 green ducks because that's more than one. I want to figure out at most 1 green duck. Okay, so now when I have these two probabilities, 0.043 of selecting 0, 0.248 when selecting 1, how I figure out the probability of selecting one or the other, I take those two probabilities and I add them. So I get 0.043 plus 0.248. When I add these together, I end up with 0.291. The probability of me selecting either 0 or 1 is 0.291. You want to put that in percentages, it's 29.1%. Okay? All right, try the second one on your own. I want you to try that. I'm going to give you a few moments to write this down, but try to see if you can come up with that second one. Okay, so it says, what is the probability of selecting more than one green duck? More than one. Can I select one? No, I want more than one. More than one green duck. Okay, more than one green duck. All right, so more than one green duck. Can I select 2? Is 2 more than one green duck? Yep. Is 3 more than one green duck? Yep. Is 4 more than one green duck? Yep. So if I look at that, I have 0.418 chance of selecting 2 green ducks. 0.248 selecting 3 green ducks. 0.043 for selecting 4 green ducks. How do I figure out the probability of me selecting 2, 3, or 4? Well, I have to add all of these up. So when I add all of these up, I get 0.709. Add all of them up, and I get 0.709. Okay? Done with this problem. All right, now comes a tricky problem. Okay? So as I look at this, we're going to have to come up with a formula. So pause the video right now and write this down. All right, so there are 4 teams in a school tournament. Team A has a 25% chance of winning. Team B has the same chance as Team D. Team C has the half of a chance of winning as Team B. We're going to create a table. We're going to figure out all of these probabilities between all of these. Okay? So A, B, C, and D. These are the 4 teams participating in my tournament. How original are those team names? A, B, C, and D. All right. As you look at Team A, what is the probability that Team A will win? Well, it says right here, 25% chance. 25%. Team B has the same chance of Team D. Huh. How do you come up with that? Doesn't give me any numbers. Well, do you know Team B? Nope. Do you know Team D? Nope. What happens when we don't know something in math? What do we plug in? X. We plug in an X. Okay? Done with that. Then, Team C has half the chance of winning as Team B. Well, what was Team B? Team B is X. What's half of X? Half X, 0.5 X. Done. That's a 0.5x, not just a 5x. Don't forget there's a decimal point there. I know it's hard to see, but it is there. All right. Now what do I do? I need to get this into an equation. What do I know about A, B, C, and D? What do I know between all of those teams? Well, I know that one of those teams will win. So what's the probability that one of those teams wins? 100%. Okay, so you're telling me that if A, B, C, and D are the only teams in this, if I add up all of these percentages and set it equal to 100%, I will come up with my answer. Okay, 25% plus X plus 0.5X plus X equals 100%. Now I just need to start by solving for X. Okay, well, I'm going to combine like terms first. So I'm left with 25% plus 2.5x. I get the 2.5x because I have 1x here, 1x here. 1 plus 0.5 plus 1 is 2.5x. Equals 100%. How do you get rid of that 25? You subtract. Subtract 25 on each side, 25%. You'll end up with 2.5x equals 75%. How do you get x all by itself? You need to divide. Why do we divide? Opposite operation. Yes, it's the opposite operation. Nice guess. Okay, so what does x equal? 30. X equals 30%. My x is 30%. Now, am I done with the problem? I solved for x. Am I done with the problem? No, I'm not finished. Because as I look at this, the chance of Team A winning is 25%. Chance of Team B winning was x. Well, we know x is 30%. Chance of Team D winning is x, which is also 30%. What is the chance of C winning? Well, if it's half of x and x is 30, this is 15%. Half of x and x is 30, it's 15%. You need to, I know you can come up with this with a guess and check type of a method. I want you to get into the frame of mind to come up with this formula. Get into that. In 5th grade, you could guess and check. And even in 6th grade math, you could guess and check. But once we hit pre-algebra, we need to start coming up with that formula. Okay? Okay. All right, here we go. Please write this down. Please write this down, and then I'll explain. All right, so we are going to give the probability of each outcome. So looking at this spinner, notice up here we have outcomes of 1, 2, and 3. Our outcomes are what possibly could happen. So as I look at this, the thing I want to remember is how many possible outcomes are there? Well, we have 3 possible outcomes. However, the total number of things we can spin and hit, the total number of sections we can hit, we can hit 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sections to this spinner. Now, they only have 3 different outcomes, but 8 total sections. All right, so as I look at this, if I have a probability, I'm looking for the probability of spinning a 1. So the probability of me spinning a 1, well, how many 1s are there? 1, 2, 3. There are 3 sections of 1s. How many total sections are there? 8. I have a 3 out of 8 chance of spinning a 1. Okay, I want you to try to finish 2 and 3. Pause and go. Okay, looking at 2. How many chances do I have to spin a 2? 1, 2, 3. Another 3 out of 8. Why is it out of 8? That's the total number of sections. Then, number 3, as I look at number 3, how many 3s do I have? 1 and 2. There are 2. 2 out of how many? 2 out of 8. However, can you simplify? Can you simplify the 2/8? Yes. Yes, you can. And that's going to be 1/4. So you have 1/4, 3/8, 3/8. Done. All right. Rolling a number cube. I want to see if you can come up with this. What is the probability of rolling a 1? The probability of rolling a 2? Probability of rolling 3, 4, 5, and 6. Okay? Think about those in terms of how many total outcomes are there. So pause now, write this down. All right? Outcome of rolling 1. I'm going to roll the dice. Shake, 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 shake. Roll. What's the chance it's going to be a 1? 1 out of 6. Shake, 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 shake. Roll. Chances of it can be a 2. 1 out of 6. 3, 1 out of 6. 4, 1 out of 6. 5, 1 out of 6. 6, 1 out of 6. Are you sick of me saying 1 out of 6? No. Good, 1 out of 6. Okay, so as you look at this, each of them have an equal opportunity of being rolled. All of them have the same chance, same probability. They have a 1/6 opportunity to be rolled. All of these are 1/6. All right, fantastic. That's all I have for you today. I will see you tomorrow. Have a great day. Bye.